tricky. So in this one, we're looking at water of crystallization. So do you remember that before? Yeah. And you've got crystals of citric acid contain water of crystallization. Citric acid is a triprotic acid. So what that means, triprotic. So for example, H3PO4 is a triprotic acid. H2SO4 is diprotic. HCl is monoprotic. So that means it releases 3 H pluses. Each molecule releases 3 H pluses. Okay. So 152 gram of the citric acid was made up to 250 centimeter cubic solution. So what I like doing, I like to sort of visually draw things for myself. So what I've got in here, I've got my citric acid. It's 250 centimeter cubic, and we have 1.52 gram of this. Okay. And then 25 centimeter cubic portion of this went into my conical flask. So here I've got 25 centimeter cubic of citric acid, right? So this is 10 times smaller, right? Because we had 250, but we took 25. Okay, so this required from a burette, this is my burette, this is just, it's not a proper diagram, this is just me sort of, I prefer to have this information visual. So, 25 centimeter cubic portions of this solution, which is that, required 21.80 centimeter cubic of 0.1 molar. It doesn't say of what. Let's assume this is NaOH. Okay, I think it's a mistake in the question. It should say NaOH. So we needed, normally it is an NaOH that we use as in acid-base titration. So my guess should be as good as any other. Okay, so here we have my NaOH. And we've got volume is 21.80 centimeter cubic and 0.100 mole decimeter minus 3. And they want us to calculate the value of N. How do I do that? Well, let's work out what we can, and then we can figure out how we can work out the value of N. Okay, so let's see what we can do. So I've got here volume and concentration, so I can work out the moles. So moles of NaOH in here will be concentration times volume. When I see 21.8, that's 0.0218 decimeter cube. Yeah, so that's going to be 0.0218 times 0.1. That gives me 0.00218 of moles. Okay, so that's how many moles of NaOH. And I will do the same here in terms of the unit. Okay, so the ratio of NaOH to citric acid, we need the ratio of that to work out the moles of citric acid. What is the ratio? Well, we know NaOH has 1 OH, and the citric acid they told you is triprotic, so that means it releases 3 H pluses. You can see that at A level, these questions get a little bit more complex, right? So what do we know? That if I have NaOH and then a citric acid, so citric acid is triprotic. So to work out the, we've got the moles of this, so moles of citric acid, okay? We need to times by 3 because it's triprotic acid. It's triprotic, so 0.00218, you times it by 3, sorry, divided by 3, my bad, you divide it by 3 because NaOH, the ratio, let me just double check, NaOH to citric acid, the ratio is 1 to 3. No, 3 to 1. Yep, 3 to 1, because one citric acid produces 3 H pluses, so 3 NaOHs are needed to cancel that, okay? So that means if I go from NaOH to citric acid, I need to divide by 3. So see, you always need to sort of like go through stuff just to, in case to not make a mistake. So the moles of citric acid, you need to divide 0.00218 divided by 3. So that will give us 0.1232727 moles. So this is how many moles of citric acid are in here. Okay, so that's in 25 centimeter cubic, right? That's in 25 centimeter cubic. But originally we had 250. So what do you need to do to make it in 250? So you need to times it by 10, because here we divided by 10 and we went from 250 to 25, but in 250 we need to times it by 10. So we get 0.00727 moles of the citric acid in 250 centimeter cubic. So that's my initial volumetric flask in here. See, that's why I like to have everything laid out visually like that. Okay, so we worked out what we could. So see, I didn't know initially how to actually calculate the value of N. However, I followed what I could calculate, which is more standard sort of titration calculation. And at least now I already got a few marks, right? Normally it's 1 mark for calculating the moles of NaOH, 2nd mark for the ratio, 3rd mark for times 10. So I already have 3 marks, maybe even 4th mark for changing the centimeter cubic to decimeter cubic. It's not always a separate mark, right? So what do I do now? Now I need to have a look at the last bit. So I know that my citric acid is C6H8O7.NH2O. So I need to know the N, right? And I know that the whole thing was 1.52 gram, right? But it's only the C6H8O7 that actually reacts with the NaOH. So these moles in here, that's C6H8O7, okay? So what I can do is, I've got moles, C6H8O7, I've got moles, 0.00727 moles, right? What is the MR of just C6H8O7? Okay, so if I just calculate it quickly, 6 times 16 plus 8 plus 7 times, 6 times 12 should have been 192. This is the MR. So this was 12, this was 1, this was 16. Okay, so if I have moles and MR, you times it 0.00727. So that's 1.3958 grams. Okay, so if I had the whole citric acid is 1.52 gram, and this section in here is let's round it off a bit, 396 gram, right? So how much is the water in here? Zero 0.124 gram. Okay, so what's the number of moles of this water? So I can do 0.124 gram divided by 18, which is the MR, and that's going to give me 0.0069. Okay, so moles of H2O, and the ratio here is 1 to N, right? So 1 to N, N is the water, right? So this is H2O, this is C6H8O7. So if my water is N, that's 0.0069, and my C6H8O7 was 0.00727. What do I need to do? I need to divide by the smaller number, which is this one, and you could see that 7 and 6, 9, it's roughly 1 to 1. The ratio is 1 to 1, so n equals 1. There's more than one way of doing it. We had the similar kind of calculation before.